going to discuss about a solution of a system of a linear equation by Gauss Seidel methods. So by Gauss Seidel methods, So for sake of a simplicity, here we consider only three unknown and three equation. So as we know that Gauss Seidel method is under the category of iterative methods. So for sake of a simplicity, here we consider three equations: a11 x1 plus a12 x2 plus a13 x3 equal v1, a21 x1 plus a22 x2 plus a23 x3 equal v2, and a31 x1 plus a32 x2 plus a33 x3 equal v3. This one is a system of a linear equation, three equation with three unknowns. Unknowns are x1, x2 and x3. And this one is the first equation, second equation, third equation. In whole, this one is a system of a linear equation. Now, if we write in this one is in a form of a matrix. So this one ax equal b. Ax equal b. A is a what? A is a a11, a12, a13, a21, a22, a23, a31, a32, a33, and x with a x1, x2, x3, and b with a b1, v2, and v3. So now first we describe the general methods, then in form of a matrix. So how we write this equation? Now here a11 x1, so we write x1 and all other term in a right hand side. So x1 equal 1 upon a11 v1 minus a12 x2 minus a13 x3. So we write in this form, and here we write x2. This term on a left hand side, all other term on a right hand side. So we write x2 equal 1 upon a22 v2 minus a21 x1 minus a23 x3, and x3 equal 1 upon a33 v3 minus a31 x1 minus a32 x2. So how we write this one? a11 x1 and all other term goes in a right hand side, then x1 equal this one. Similarly, second term on a left hand side, all other term on a right hand side. Third term on a left hand side, all other term in a right hand side. Then we find this one x1, x2, x3. So this one is an iterative scheme, x1, x2 and x3. So initially we assume that this set of a vector is a solution. x1 0, x2 0, x3 0, x3 0, x3 0. So suppose this one is a initial solution, initial iteration, and here we denote this one is by the vector x0. What is the meaning of this one? x0 denote the values of unknowns at initial level, x1 denote the value after first iteration, x2 denote the value after second iteration. Similarly, here we use the notation xk with the values of unknowns after kth iteration, and xk plus 1 with the values after k plus 1th iteration. So here initially we assume that x1 0, x2 0, x3 0 with the initial solution. Then what will happen in a iteration method, in a Gauss Seidel method, as we calculate new value of x1, to calculate next value, we use the new value of x1. To calculate the x3, if we have a new value of x1 and x2, then to calculate the value of x3, we use the new values of x1 and x2 in a same iteration. This one is a difference between Gauss-Jacobi and Gauss Seidel. In a Gauss-Jacobi methods, after calculating all the values in a next iteration, we use the initial value to find out the values of x1. But in a case of a Gauss Seidel methods, to find out the values of x1 new, means x11, we use what? x20 and x30, because this one is the updated value, last updated value of x2 and x3. So here we write what? 1 upon a11 v1 minus a12 x20 minus a13 x30. Now, to find out the value of x2, what we write here, x21 equal 1 upon a22 v2 minus a21 x1. So we have a updated value. Updated value is what? x11. So here we use a21 x11 minus a23 x3. New value of x1. In a next, to calculate the value of x2, we are going to use what? Value of x1, updated value of x1. So similarly, now we have two values, x11 and x21. So to find out the value of x31, we use the value of x11 and x21. But in a Gauss-Jacobi, what will happen? To find out a value of x21, we use the what? x10. And similarly, what is the value of x31? x31 equal 1 upon a33 into v3 minus a31, now x1, 1. Here we use the updated value x11 minus a23, x21. So, in case of a Gauss-Jacobi method, here we use what? Here we use the x01 and x30. Here also we use the x10 and x20. But in a Gauss Seidel methods, we use what? We use x11 as we calculated the value of x11 to find out the next value, we use the value of x11. And we have x11, x21, then we find the value of x31. To find out the value of x31, we use the value of x11 and x21. So, in a similar manner, this one is for first iteration. Now, in a second iteration, what will happen? In a second iteration, this one is a first iteration. In a second iteration, x12 equal 1 upon a11 v1 minus a12 x21 minus a13 x31 and x12 equal 1 upon a22 v2 minus a21 x1, new value of x1, x12 minus a23 x31. And to find out the value of this one is x22, x32, this one become what? This one become 1 upon a33 v3 minus a31 x12 minus a32 x22. So this one is a procedure, means as we calculated new value of x1, to find out the value of a new value of x2, we use the new value of x1. To find the value of x31, we use the new value of x1 and x2. Now in a similar manner, this one is a procedure, general procedure. To find out up to a desired level of accuracy. What is the desired level of accuracy means? If the values of x1, x2, x3 up to after certain iteration repeated not only one value, all three values repeated up to a 2 decimal places or 3 decimal places or 4 decimal places, then we say that now we stop the procedure, means we say that we stop the procedure and write down the values of x1, x2 and x3 up to a desired level of accuracy. Now we are going to describe in the form of a matrix how we find a solution of a system of a linear equation by Gauss Seidel method. Means we try to write a iterative scheme. Means a iterative scheme, a relation between k plus 1th iteration and kth iteration. So x1 2, x2 2, x3 2. So in general we able to find out the solution of this one. Now how we write in the form of a matrix. So x1 k plus 1 equal what? 1 upon a11 v1 minus a12 x2 to the power k minus a13 x3 to power k. And similarly x2 k plus 1 equal 1 upon a22 v2 minus a21 x1 k plus 1 minus a23 x2 x3 to power k. And x3 k plus 1 equal what? Equal 1 upon a33 v3 minus a31 x1 to power k plus 1 x1 k plus 1 minus a32 x2 k plus 1 k plus 1. Now x1 k plus 1, x2 k plus 1 and x3 k plus 1. Now we try to write this one in form of a matrix. So how we write this one in form of a matrix? Now we try to write this one in form of a matrix. Now this matrix A can be written in a sum of 3 matrices. A equal what? A equal, here we write A equal L plus D plus U. What is the L? L is a lower triangular matrix. L equal what? L is a 0, 0, 0 and what is the values? A21, 0, 0, A31, A32 and 0. This one is the value of a L, lower triangular matrix. And D is a what? D is a diagonal matrix. D is a diagonal matrix. So what is the value of this one? A11, 0, 0, 0, A22, 0, 0, 0, A33. This is the value of a D. And similarly we write a upper triangular matrix U equal what? U equal 0, U12, sorry, not a U12, A21, A12, A13. Just we erase out this one. Erase out this one. Then this become what? This becomes 0, A12, A13, 0, 0, A23 and 0, 0, 0. So you see A equal L plus D plus U. So if we add these values 0, A11, 0, then what will happen? Then we find the what? We find the A. So A equal L plus DU. So if we find L plus D plus U, this become what? This become A, means A11, A12, A13, A21, A22, A23, A31, A32, A33, this one. So simply add with, then we find the A11 matrix A. This one equal to what? This one is a A. Now, we use these values LDU. So what is our aim? Our aim is to write a iterative scheme having a what? Xk plus 1 equal H xk plus C, where x is a what? X is a column vector having a how many number of unknowns? X1, X2. In this case, there is a 3 unknowns, so X1, X2 up to X3. So H is a matrix and C is also a matrix. So how we write this expression in this form? How we write this expression in this form? So how we write this one in this form? So here just we erase out this one, what we erase. So here we use the LDU, so I am not going to erase this one, I am going to erase this one, means this one. If we erase this one, now we try to arrange, means the coefficient of a k plus 1 on a left hand side and the coefficient of a k on a right hand side. So here a11 x1 k plus 1. So here we write a11 x1 k plus 1 just multiply it here, and this one here we write 3 terms 1, 2 and 3. Here we write what? Here we write minus a12 x2 the power k minus a13 x3 to power k plus v1. This one is a value. Now similarly, second equation, there are two terms of a k plus 1. So first we write this term, then we write the x2. So multiplied by this one, then this become what? Plus a22 x2 to power k plus 1, and here now this one multiply and this become on a left hand side, then this become what? a21 x1 to power k plus 1. Now other terms become what? Other terms become on a left hand side, other term become, there is a one term of a k, and that term is a what? a23 x3 to power k plus v2. Now similarly, if we write a third one, there is a 3 term of a k plus 1. So what is the first term? a31 x1 k plus 1 plus a32 x2 k plus 1 plus a33 x3 k plus 1 equal what? Equal this one equal to what? Plus v3. And all other coefficient become what? 0. 0 into x1 to power k minus this one. Also there is a 0 plus 0 plus this one, and 0 plus 0 plus 0 and this term. So also here if we write the coefficient of x to the power k is a what? 0, and coefficient of x3 is also a 0. So if we closely observe this system of a linear equation and the lower triangular matrix, diagonal matrix and upper triangular matrix. So what you see here, if we add L and D, then we find what? A11, A21, A22, A31, A32 and A33. So what will happen here? If we write this one in a matrix form, what is the matrix? A11, what is the coefficient here? 0. Here coefficient 0. Here this one is a A21, here A22, here 0, here A31, A32, A33, and this one multiplied by what? X1 k plus 1, X2 k plus 1, X3 k plus 1 equal, and it be right here in a matrix form. Here in a matrix form, this become what? 0 minus A12 minus A13, 0, 0 minus A23. I think this one is a minus, not a plus. This one is a minus. Minus A23, and we erase out this one and try to write A23, and here this one is a 0, 0, 0. In a form of a what? In a form of a, here it be multiplied by X1 k, X2, X2k, and X3 k. So plus what? Plus B1, V2, and V3. So if we closely observe this expression equivalent to this one, if we multiply by row by column. So A11, X1 to power k plus 1, all the term become 0. A21, X1 k plus 1, A22, X2 k plus 1, A31, X1 k plus 1, A32, X2 k plus 1, A33, X3 k plus 1 equal what? Equal this one multiplied by this one minus A12 X1 X to the power k minus A13 X3 to power k plus B1. So this one is a matrix form, and if we closely observe, this one is a what? Here if we add L and D, lower triangular matrix and diagonal matrix, L plus D become what? This one is a what? This one is a L plus D. So here we write what? D plus L or L plus D. This one is a D plus L. D plus L. D plus L. Now in a vector form, what we write here? This one is a X, X1, X2, X3. So this one is a X to power k plus 1 equal what? Equal, this one is a minus time of a what? Minus time of a U. Minus time of a U X k plus what? This one is a V. This one is a vector V in a matrix notation. This one is a vector V. Now almost we have done all other things in a matrix form. Now just we try to explain this one. Now we find a what? D plus L xk plus 1 equal minus U xk plus V. So now multiplied by the D plus L inverse, because we try to find out the relation between xk plus 1 and xk, we try to write in a form of a iterative scheme. So we try to write in this form. We try to write in this form. We try to write in this form. This one is a what? This one is a iterative scheme. So now, so multiplied by the D plus L inverse. So D plus L inverse into D plus L inverse, this become what? This become unity matrix. So multiplied by D plus L inverse, this become xk plus 1 equal minus D plus L inverse U xk plus D plus L inverse V. So if we compare with the standard result, means xk plus 1 equal h xk plus what? C. So what is the value of h? H become here h equal minus of D plus L inverse U, and C is a C equal D plus L inverse V. So this one is a what? This one is a iterative scheme. This one is a iterative scheme. This one is a iterative scheme for the Gauss Seidel method. This one is a iterative scheme for the Gauss Seidel method. Iterative scheme for Gauss Seidel method. Gauss Seidel method. Gauss Seidel methods. So this one is a theoretical concept, theoretical explanation of Gauss Seidel methods. So either in general we find the value of our initialized, we value x10, x20, x30, then we find the x11, x21, x31 with the help of our initial value, x1k plus 1, x2k plus 1, x3k plus 1. And otherwise we write in a form of a matrix, means for a given value of a we write a L, D and U, then directly we write what? Iterative scheme. This one is iterative scheme, means xk plus 1 is equal h, xk plus c, with the help of this one h, this one is a d plus minus d plus L inverse U and c, d plus L inverse V. Once we find the values of this h and c, then we write the iterative scheme, then we initialize the value x10, x20, x30, then we find the value of a next iteration and next iteration up to a desired level of accuracy. Now to discuss what is the, either this one is a true for all initial value or there is some condition, means like now when we apply a Gauss Seidel methods. So if we start arbitrary, as we know that any iterative scheme can be only applicable if this one converges to our actual solution or approximate solution. So there is some condition on a given system of a linear equation. If that condition satisfies, then we ensure that if we start from any initial value, then we move to our approximate solution or exact solution. So what is the condition? And that condition is also known as a what? That condition is also known as a, means a sufficient condition for the convergence of a system of a linear equation for if we apply any iterative scheme. So what is the condition? And this one is also known as a diagonally dominant condition. Diagonally dominant condition. So here we are going to theoretically, we are going to prove this result for the two variables only. Similarly, we assume that this one is a true for three variables, and similarly this one is also true for, means by mathematical induction we assume that this one is a true for what? This one is a true for n variables. So condition, sufficient condition for the convergence. Sufficient condition for convergence. Sufficient condition for convergence. Convergence of system of linear equation. Linear equation by iterative scheme, by iterative method. This one is a very long. So sufficient condition for convergence of a system of a linear equation by an iterative scheme. So here just we put what? Just we write two equation, a11 x1 plus a12 x2 equal what? v1. So a21 x1 plus a22 x2 equal what? v2. So as in any iterative scheme, we write what? We write this one in this form, x1 equal 1 upon a11 v1 minus a12 x2 in this form. Similarly, if we write x2 equal what? x2 equal 1 upon a22 v2 minus a21 x1. So as we know that in case of a nonlinear, if any equation is written in this form, x equal what? X equal phi x. So what is the criteria for convergence? Criteria for convergence is a mod of a phi dash x. Mod of a phi dash x is a less than 1. Mod of a phi dash x is a less than 1. In a similar manner, here we assume that what? x1 is a function of a what? Function of a x1 and x2. And x2 is also one another function of a x1 and x2. Now, according to this one, what is the criteria for convergence? Mod of a del f1 upon del x1 plus mod of a del f1 upon del x2 is a less than 1. And mod of a del f2 upon del x1 plus mod of a del f2 upon del x2 is a less than 1. So now what is the value of a del f1 upon del x1? Del f1 upon del x1, here this one is a what? This one here we assume that what? Here we assume that this one is a function of a f1 x1 x2. This one is a function of a x1 x2 x1 x2. So what is the del f upon del f1 upon del x1? Del f1 upon del x1 equal to what? 0. So if we find del f1 upon del x1 equal to what? 0. Del f1 upon del x2 equal to what? Equal minus a12 divided by a11, and del f2 upon del x1, this one, then minus a21 upon a22, and del f2 upon del x2 equal to what? Equal to 0. So now if we put these values here, then what will happen? This one becomes 0 and this one become a12 upon mod of a11 less than 1, and this implies that mod of a12 using the property of a mod, this become what? a12 become what? a12 become a12 is a less than a11, and similarly if we simplify this one, second set of equation, then what will happen? a21 is a less than a22. So a12 is a less than a11, a21 is a less than a22. So what is the meaning of this one? Meaning of this one is a mod of a11 is a greater than mod of a12, and mod of a22 is a greater than mod of a21. In a similar manner, if we write for a system of a linear equation having three unknowns means a11 x1 plus a12 x2 plus a13 x3, means a system of equation is this one, a11 x1 plus a12 x2 plus a13 x3 equal v1, a21 x1 plus a22 x2 plus a23 x3 equal v2, and a31 x1 plus a32 x2 plus a33 x3 equal what? v3. So in a similar pattern, what we get in a similar procedure, we get what? Means this one is f1, this one is f2, this one is f3. If we write in this form, then f1, f2, f3 and find a partial derivative, then if we simplify, then what is the result? Result become what? A11 is greater than mod of A12 plus mod of A13, and similarly A22 must be greater than mod of A21 plus A23, and mod of A33 is greater than mod of A31 plus mod of A32. So what is the meaning of this one? Diagonal element modulus value means mod value of a diagonal element must be greater than modulus value of a remaining coefficient of a remaining two elements, means mod of a A11 greater than mod of a A12 plus A13, and mod of a A22 is greater than mod of a A21 plus A23. So in this way, mod of a A33 greater than mod of a A31 plus mod of a A32. So if we generalize this result, means if there is n unknowns, then mod of a A11 is greater than mod of a A12 plus mod of a A13 up to mod of a A1n. So if we closely observe, these are the diagonal elements. These are the diagonal elements. A12, A13. These are the diagonal elements. So this one is called diagonally dominant. Means mod of a diagonal elements must be greater than sum of a mod of a other values. Most of a diagonal element must be greater than sum of a mod of a A21 and A23. Similarly, if there is a n values, then obviously, if there is a n values, then we able to find out what? We able to find out this result for the n values. So this one is called what? Diagonally dominant. This one is a sufficient condition. This one is not a necessary condition. What is the meaning of this one? This one is a sufficient condition, means without satisfying this condition, maybe the given system of a linear equation converges to our approximate solution or actual solution. So what we conclude that if this condition satisfies, then there is a guaranteed the given system of a linear equation converges to our actual or approximate root. But if this condition does not satisfy, then you cannot claim the given system of linear equation does not converge if we choose any initial approximate value. So this one is a theoretical explanation of a Gauss Seidel method. So next we are going to take one example and try to solve by general procedure, and second one with the help of a matrices, how we solve this one. Now we solve a numerical example based on a Gauss Seidel method using the general procedure, not using the matrix form. So how we solve this one? First we check this one is a diagonally dominant or not. So what is the value of A11? If we compare, A11 is a what? 10. So A11 here, A12 is a -5, A means here we write in a form of a matrix, not only this one. If we write in form of a matrix, this one become what? 10, -5, -2, 4, -10, 3, 1, 6 and 10. This one is a x1, x2 and x3. This equal to 3, -3, -3. So what is the diagonal elements? 10, -10, -10. So we check this one mod of 10, mod of A11, mod of A11 must be greater than, here if we write general term. So here mod of A11 must be greater than mod of A12 plus mod of A13, and mod of A22 is greater than mod of A21 plus mod of A23, and mod of A31 must be greater than mod of A31 plus mod of A32. So now we check these conditions satisfy or not. So 10 is greater than 5 plus 2, 5 plus 2, and 10 is greater than 4 plus 3. 4 plus 3, this one is a 7, this one is a 7, and 10 is again greater than 6 plus 1, 7, means all three conditions satisfy. So if all three conditions is satisfied, then if we write in a general form, then we able to find out what? Then we able to find out the solution for any initial approximate value. So how we write this one? Here we write x1 equal what? If we write this one here in this way, what is the value of x1? x1 equal 1 by 10 inside 3 minus 5x2 plus 5x2 plus 2x3. This one, this. Now x2 equal minus 1 upon 10, minus 1 upon 10, this one, minus 1 upon 10 inside minus 3 minus 4x1 minus 3x2. And if we simplify this one, then this become what? Plus. Okay. Similarly, if we write x3 equal what? 1 by 10 here minus 3 minus x1 minus 6x2 and already we checked the criteria for convergence, and criteria for convergence already satisfied. So for any initial value, this must be converges to our approximate solution. So suppose we assume that x0 is a what? This one is the initial value 0, 0 and 0. 0, 0, 0. What is the meaning of this one? x1 0. x1 0 with the 0, x2 0 with the 0, x3 0 with the 0. Now, what is the value of x1 1? So x1 1 become what? Here we use the values of x2 0 and x3 0. x1 1 is a 1 by 10 and all other value with a 0. So 3 and all other value plus 5x2 0 plus 2x3 0. This one. And x2 1 become what? x2 1 become what? So what is the value for this one? If we simplify this one become what? This one become, if we erase out this one, and x1 1 become 3 by 10, this one is a 0.3. This one is the value of x1. So to find out the value of x2 1, we use the value of x1 1. So how we find the value of x2 1? x2 1 become what? 1 by 10 inside 3 plus 4x1 1 plus 3x2 0. x2 0. So if we simplify this result, so this become 1 by 10, 3 plus 4x1, 4 into 0.3. So if we simplify this become point what? 3 plus 0.12, this become what? This become 3 and 1.2, so 3 point, this becomes 0.42. Similarly, what is the value of x31? x31, again we use the value of x11 and x21. So what is the value of x31? x31 become 1 by 10 minus of 3 minus x11 minus 6 x21. So this become what? 1 by 10 minus 3 minus x11 is what? 0.3 minus 6 into x21. x21 is a 0.42. So if we simplify this one, x31 become what? x31 become minus 0.582. 582. So what we conclude here, x1, x2, x3, this one is the iterative scheme. To find out, initially we assume that 0, 0, 0 be the solution. x1, 1 be the 1 by 10, 3 plus 5 x2 plus 2 x3, 0. Okay? We use the initial value. This one is x1, 0, x1, 0, x2, 0, and x3, 0. x3, 0. So we use this value, then we find the 0.3, then again, when we try to find out the value of x21, we use the value of x11 and x2, 0. To find out the value of x31, we use the value of x11 and x2, 1. So this one become what? This one become means first iterative value. Here we noted down the value of x11, x11, x21 and x31. So x11, x21, x31. So to find out the next values, x21 become what? 1 by 10, 3 plus 5 x21 plus 2 x31. Means we use the value of this and this to find out the value of what? x22. Similarly, x12. Similarly, x22, 1 by 10, 3 plus 4 x21 plus 3 x21. In a similar manner, if we put these values, means a 0.3, 0.42 minus 0.582 here, and replace what? Means k by the 1, k by the 2, k by the 3 in iterative scheme, then we find what? x2, x3, x4 and x5. These are the values. So if we closely observe here, x3 and x4 and x5, x4 and x5, then what we observe? We observe that this one is a character 2, this one 3, 4 and 5, 0, minus 5, 0. Here this one is also a 5, 0, 2, 8 and 3, 4. Means the now solution means solution is repeated up to 2 decimal places. So up to 2 decimal places after 5 iteration, we say that x1 is a what? x1 is a 0.34, x2 is a 0.28 and x3 is a minus 0.50. So this one, how we find the solution with the help of a Gauss Seidel method using the general procedure. Gauss Seidel method is also known as a what? Also known as a displacement method. Why this one is known as a displacement method? Because here we write x1 equal this one. Means if the displacement difference of these two become what? Difference of these two become 0. Difference of a left and right hand side become 0. Then if for such values of x1, x2, x3, be able to find out such values of x1, x2 and x3 for which left and right hand side become 0. So if difference of this one, v1 minus all other. So this displacement, this one is a difference, this one is a difference, displacement. So we try to minimize this displacement. If this displacement becomes 0, then we able to find out actual solution. If this displacement is nearer to the 0, then we able to find out approximate solution. So this one is a procedure how we find the solution with the help of Gauss Seidel methods. So next we are going to discuss about how we find the solution of any system of a linear equation by Gauss Seidel method using the matrix form. Okay, thank you. Today we are going to finish this lecture with this numerical problem. Okay, thank you. Thank you for watching my video.